Alright, new lesson. Good to see y'all again. Working on multiplying rational expressions. Well, let's start with regular rationals, also known as fractions. How do we multiply these two? Well, we multiply right across. So we get 30 over 40. And then if we're smart, we reduce. Could we have reduced originally? Yes, we could. You'd get 3 over 4 either way. Doesn't matter. How about we actually have a rational? You can mash them all together first if you want, but I think it'd be easier to start canceling. So we have an x here, x squared, that'll be x to the first. We have an x squared, we have an x to the third, that'll be x to the first. X to the first are going to cancel. I don't think first is a word, but I'll try it anyway. 1 here, take out the 3, get a 2 here, take out the 2 here, get a 6, take out the 2 here, get a 3, and we end up with 1 over 3. What a mess. Don't forget, go back to the original equation. X can't equal 0. Always check your extraneous values. So, try a complicated one. I'm not going to rewrite it. I don't know if I can cancel anything from here and here, or from here and here. It's a little too complicated looking as it is. So we got to factor. So I'm going to factor it down here. I can pull out a 3x, and I'll be left with an x plus 1. I can pull out a 4, and be left with x squared minus 6x plus 6, which is hideous. Is that right? Nope. Plus 9. Now it's not so hideous anymore. And x minus 3, x minus 1. Pull out an x here, left with x minus 1. I'd like to keep going, but I'm not ready yet. I need to factor that bottom on the left, this piece here. So I believe I can put that, it's a perfect square. X minus 3, x minus 3, x minus 1, x, and x minus 1. Now, we can cancel these whole factors, this whole piece, or this whole piece, or this whole piece, or this whole piece, if they match up. We can't just cancel individual x's or numbers, because they're a whole piece. So we can get rid of the x minus 3, and get rid of the x minus 1. All we're doing is simplifying. So 3x, x plus 1, over 4, x minus 3. Never done, because it's math, and math hates you. So let's go up to this step here, since that's where it's all factored and we haven't canceled anything until after that point. Can't have 3, writing things twice. Can't have 1. That's it. Should try this one on your own. You have the note sheet with you. If you want to pause, go ahead. Otherwise, I'm going to run right into it. X plus 3 times x plus 2, x plus 3 over 1. This is where I'll get my extraneous values, or pardon me, excluded values. X cannot equal negative 2 or negative 3. And then I'll write them in after I'm done. Cancel my x plus 3. 5x over x plus 2. X cannot equal negative 2 or negative 3. You may or may not have noticed that factoring is a pretty handy skill to have. And if you don't have it, you better go back and get it. Otherwise, you're going to spend a lot of time working out these problems. Moving on, how do we divide? 3 over 4 divided by 27 over 8. All we do is flip one piece, the second piece, and we turn it into a multiplication problem. Nothing has changed. Again, I like to cancel first, and we multiply across, we get 2/9. When I rewrite this problem, I will start flipping it right away. So the 14x squared goes on top, and the 5x on the bottom. Looks like we have an x squared here. I can cancel across. These two will be gone. looks like 7, 14, 1, and 6. So we end up with 12x to the third. Before we canceled, we have to look at these two pieces here and here. So we just can't have x equal to 0. Off we go. Flip it, and at the same time I'm going to factor it, just to save time. So I'm going to factor this piece. I can pull out a 7x, leave me with x minus 1. On the bottom, that's x plus 3 times x minus 1. 3 times negative 1, negative 3. 3 plus negative 1, 2. Looks good to me. Flip it, and I'm going to do the bottom first. X plus 1. And I think the top looks like an x minus 8, x minus 1. Nope. X plus 1. Negative 8 times 1, negative 8. Negative 8 plus 1, negative 7. It's a beautiful thing. Cancel my x plus 1. Cancel my x minus 1. Interesting. Everything stayed on the same side this time. 7x times x minus 8 all over x plus 3. Go back to the previous step here. Didn't want to take my ink pen. Here, here, and here for my excluded values cannot be negative 3, negative 1, or 1. I like to write them in order. You certainly don't have to. And last but not least, start factoring right away. 2 comes out, x squared plus 8x plus 12 over 3x squared. And this is actually x plus 6 over 1, so we can just pull out an x plus 6. Well, note this x plus 6 part here, since we're somewhat evil, but not completely evil math teachers, I'm guessing that that's going to factor out of here somewhere. So when you go to factor, you might want to look for an x plus 6 up top, but hey, what do I know? I'm just the teacher. 2, and I'm just going to take a wild guess that x plus 6 is one of them. 6 times 2 is 12. So let's try that. 2 times 6 is 12, and 2 plus 6 is 8. Shocking. Over 3x squared times 1 over x plus 6. Cancel equals, can't cancel anything else. 2x plus 2, 3x squared, comma. Let's go looking for our excluded values. Looks like just a 0 and a negative 6. X cannot equal negative 6 and a 0. That's it. Get going on your math. Try your worksheet. Going to be moving along pretty quickly tomorrow to make sure we have enough time to get everything done by the end of the year. You're responsible to get it done yourself.